All right, and now I'd like to ask you random questions. So
Yeah.
this basically is one, an advertisement, right? I've said that before, and this is also a chance for my listeners to send in questions if they have any questions. That I give them a chance to ask any questions. I give them a couple of weeks to look at your papers and send me some questions and see if they actually want to venture any,
Right.
which doesn't happen a lot, but
Yeah.
it's it's nice to give them a chance. Okay, so I'll just start with the random questions that I have. The first one is how do you approach your research? How do you get ideas for things to think about or to write about?
Um, a lot of it certainly comes from discussions, going to conferences, reading other people's work, for sure. I mean, this is the main injection of new ideas, right? So you're always, once you've got your research career started, maybe towards the end of PhD when you're starting postdoc, you will by that point have a bunch of projects on the go. The way new projects start is kind of by not being too focused on what you're already doing and just being on the lookout for new interesting things that might catch your eye, which might be new papers on the archive which seem interesting, or going to the seminars and having discussions with people afterwards, and you have a thought based on what someone says in the seminar and actually following through and discussing it with them afterwards. So the social side of science really is like a big source of the new ideas, that's for sure. Yeah.
Excellent. So that goes in the next one, but it doesn't have to be quite that radical. Or I mean, you go to the conference, you say I've got this machine, you've got that machine. I mean, pretty soon you have a collaboration. That's it's not too embarrassing. But what sort of things? Just you're at a conference. You don't have to name any names.
Yeah, blanking a bit.
You're blanking a bit. Okay, so it was a good
Blanking a bit,
conference. Okay,
yeah.
yeah, all right. Okay, so
I mean,
I mean, I won't push you. I won't push
a lot of conferences recently certainly end in a kind of COVID explosion, that's for sure, but I don't know if that's appropriate.
you. Yeah, I,
Yeah.
I went to one about a month ago, and I didn't come back with COVID, but my wife still made me stay on one side of the house for a few
Yeah,
weeks.
I mean, the last conference I went to, maybe there were five of us sharing an apartment,
Mm-hmm.
and by the end, I think 80%, let's say, had COVID in
Okay.
this apartment. Yeah,
All right.
not entirely a laughing matter, of course, but
Well,
we're all fine. We're all fine.
okay.
Yeah.
So, let's see. Well, I was when we were talking earlier, you said that you spent your entire, well, maybe not your entire education, but your undergraduate, your graduate, and a postdoc all at Cambridge. So, one thing I found is that you know people are really interested in you know basically how Cambridge works, right?
Mm.
And which is a little odd because obviously it's a long way away. But if you compare my students who go from 100-person class to 100-person class to 100-person class, it might be a little bit different. So could you talk about especially the educational part of your experience at Cambridge, not the really fun part?
Mm. Yeah, so the undergraduate in Cambridge, and it's the same in Oxford, is quite special, in the sense that the institution has a funny structure, right? So as well as having the different faculties, the different departments, which is where the big lectures are, like what you described, it's also split into a bunch of what we call colleges. So there's 30 odd colleges in Cambridge. These are all these nice, well, for most of them are these nice old buildings in the middle of town, and maybe the first years live there and pretend you're in Harry Potter or something. And the colleges organise small scale teaching, what we call supervisions. So for example, when I was a first year studying natural sciences, I would have had 4 hour-long supervisions a week, which are 2-on-1 tutorials, basically with a senior fellow, or if you're unlucky, with a PhD student who has to teach. So this was, I mean, this was really incredible because, you know, you have all of this contact time with an expert. It's just you and one other student, and, you know, you're stuck on problem 4. You can really just ask as many questions as you want until you understand problem 4. So for me, I found it like, you know, it was an amazing way to learn. Very expensive to provide, of course. All this small scale teaching, but you know, that complementing big lectures and labs is great. I found most people find the same.
Okay, and I think that's the part that everybody's so interested in, is that, and also, and they never really think about that second part, that it's so expensive, right?
Yeah. So this is a question for the UK government. You know, like, we have a system where every degree at every uni basically costs the same amount of money due to how they, you know, manage the funding. But obviously these degrees, if you're studying medicine at Cambridge, for example, it's extremely expensive to provide that course.
Okay. And then you moved on to doing your graduate work there.
Yep.
Now, do you directly go into research? That's how I understood it, or do you take a lot of classes as a graduate student?
Directly into research. So yeah, exactly. That's the expectation, at least. But that's quite a tall order because, you know, if you come from, say, a 4-year combined undergrad and master's degree, which most British educated students do, you don't really know that much about quantum field theory to start, you know, coming up with these models and stuff that we were talking about in the earlier. So
okay, and then you went on and did a, is it a postdoc? What is it called? Something else?
yeah, it was a postdoc in Cambridge, so in the same group in the Department of Applied Maths and Theoretical Physics. So that's where I did the PhD, and then also did a 2-year postdoc there afterwards.
Okay. And were any of the undergraduates unlucky enough to have you as their yes?
Loads of them. Yeah.
Okay. Do they keep in touch? Do they call you at all? No.
A few of them invited me to the pub a few times.
Oh, okay.
So I thought that was a good sign. But yeah, I did loads of teaching in Emmanuel College, which is where I studied for undergrad. So while I was a PhD student and a postdoc, I did a lot of undergrad maths teaching to the first years, which I loved. It's a great course and the students were great. And yeah, this was, you know, at least 4 or 5 hours of my week every week was teaching these tutorials that I mentioned earlier.
Okay, excellent. Is there anything else that you think anybody would be interested in all that? I mean, I assume the postdoc is more or less like every other postdoc, which is, you know, you do a lot of thinking, I guess, and write a lot of papers.
Yeah, I think it's quite similar. Yeah. Oh, well, for me, actually, the postdoc was COVID era. So yeah, it was mostly from my living room at home.
Okay. Well, that's, well, I don't know what your living room is like, but
it's very nice. Yeah.
Okay, good. Okay, so let's see. Are you happy, or do you want me to ask you a quiz question?
A quiz question?
Yes.
Well, it depends what it's about, but yeah, you can go for it, and then we can edit it afterwards to make me sound smarter.
Okay, yeah. So what does it mean to measure a quantum state?
To measure a quantum state?
Yeah.
So thinking back to your non-relativistic quantum mechanics, the old school 30s quantum mechanics.
Oh yeah, the early stuff.
Yeah. Well, you know, the traditional understanding of measurement is via this idea where, you know, your state could be in a superposition of many different quantum states evolving with time, and then you make a measurement, and the system somehow decides and collapses into one state. And the thing that you can calculate is the probabilities for you to measure what state A or state B or state C. Like, this is the thing you can calculate using quantum mechanics. Is just the probabilities, but when you do a measurement, you'll measure one thing, and if you do loads and loads of measurements, I guess probabilistically you can test your calculations, right? This is the kind of traditional interpretation.
Okay.
The same is true at the LHC, right? You collide two protons. There's no fact of the matter that tells you when you collide two protons what final state you'll get, because it's a quantum process. When you make that measurement, the outcome of it is just probabilities that are determined. And if you collide, you do enough billions of proton-proton collisions, you can predict the distribution of events. That's the thing that you can predict. So this is the weirdness of quantum stuff, right?
Okay, so how many billions or trillions of protons need to get smashed together to pick up your GeWF?
Oh my gosh, yeah, I wish I knew that. That is, I'll say something completely unreasonable, I think.
Oh, okay. All right. Well, that's great. So like I said, this is an advertisement. If you have anything short to tell anybody about it, about your theory. Your theory's electroweak flavor unification, which is something I'm going to say that most people haven't heard about, even though
I'm very surprised and flattered that you somehow managed to hear about it. So this is great news for me.
Okay. All right. Well, excellent.
Very new stuff. Yeah.
Well, I'd like to thank you very much for coming on, and I hope everybody who's watching this will go and listen to your or listen to the interview with you. That'll be on Physics Frontiers. Thanks again.
Thanks a lot. Cheers, Jim. Thanks.
Okay, bye now.